Hello, grade 9s. Today we are tackling the last section of the notes, which is modeling and analyzing the data. This should be 4.6 in our books, not 4.5. My bad. Okay, so we've tackled a lot of things in this unit so far. We tackled trying to figure out what data we should collect. We tackled the different methods of collecting data. We've tackled different ways to avoid bias in our data collection. We've talked about, if we can't do a census, what are the different types of samples that we should collect data from. Now, at this point in time, we are assuming that we've done everything well. We've sent out or actually collected that data, and now we are taking that data that we've collected and trying to do those next steps with it. Now, hopefully, our data will help us make decisions about how to answer a focus question. So kind of tying it back to, let's say, that uniform piece that we talked about. Our focus question was, should changes be made to the uniform? Hopefully, if we collected data about that, we would not only be able to answer yes or no, but we would be able to use that data to help us kind of make those next steps. Now, oftentimes when you collect data, that data might be kind of unorganized, hard to interpret if you have, let's say, 100 responses and you're just looking through page after page after page of data. So oftentimes we want to present our data in ways that make sense and hopefully can allow us to identify patterns or trends. That's the dream. So in order to do so, we represent that data in a graph. Now, there's different types of graphs, and there's 4 of them that we have here that we're going to be talking about. But each of the different graph types are used for kind of slightly different things. Of course, there are more graph types than just these, but these are kind of very common ones. So the first type of graph is a line graph. So a line graph can be used for quantitative data. Quantitative data deals with numbers, usually things that you're actually measuring. So say, for example, height you would measure with a measuring tape or something like that. That would be considered quantitative data. Time is also something that's measurable. So we could either use a stopwatch if we're talking like seconds, minutes, hours, etc. But we could also measure time in days or months or years or things like that. Line graphs are really good at showing trends over a period of time. So as time goes on, what's happening with the other piece of data? What's happening with, for example, the temperature in Winnipeg? Or what's happening with a particular sales for, let's say, fanny packs, or a particular like a Stanley Cup? Are the sales going up first and then going down? Are they only increasing? Are they only decreasing? What do we see? We also sometimes use line graphs if we want to show the relationship between 2 variables. So we don't always have to use line graphs to show a trend over a period of time like we have here. We could also use line graphs to show how one variable and another one are related. So think about like the census at school that we did. Maybe we want to see if there's a relationship between the size of your foot and the height of you, right? Maybe there's a trend, the bigger your foot, maybe the more, the taller the people tend to be, and the smaller your foot, the shorter you tend to be. I don't know if that's true, but that's something that we can see if there's a relationship between those 2 particular variables. Let's really quickly analyze this graph. This is an example of a line graph. Usually with a line graph, we get data points, and then we kind of make a line or a curve of best fit so that we can see a pattern. Now, when I take a look at this, I have my time along that bottom horizontal axis, and I have temperature along that vertical axis going up and down. I have some sort of title here, which is ideal when I'm taking a look at that data, and I could see a pattern. Now, I have 2 lines going on here, and it doesn't technically have a legend that tells me what those 2 lines represent, But I could imagine that the red represents probably that average high temperature, whereas the blue likely represents the average low, right? Because every day if you check the weather network, they'll give you the high for the day and the low for the day. Likely what's going on here. Now, if I look at all this data and I plot it, I can see a pattern going on. I can see that in the summer months, it's higher, and in the winter months, it's lower, and in the spring and fall in between, it kind of fills in those blanks, right? From the beginning of the year to the end of the year, temperature goes up, and then temperature goes back down. And that's true for both the low and the high. Now, I imagine that these are averages, because if we look at something like the high for July, it says 25, and I know we've had temperatures way over 25, but this is the average temperature, right? Because every day in July is different. So if we're looking over maybe a span of many years of data collection, maybe we're saying 25 is the average high for the month, okay? But that's what we've got here. I could also use this data. Let's say it's collected, it doesn't say in the graph that I have here, but maybe it was collected between the year 2000, the year 2020, and these are all of our average temperatures. And I want to decide what time of year was best for, I don't know, let's say a camping trip. Now, I don't like camping when it's way, way, way too hot, because you're going to spend most of your time outside. You want to avoid heat stroke. Like if there's no lake nearby, that there's no way for you to cool off. But I also don't want to camp when it's freezing cold, because I want to be comfortable. I want to have a good time. So I can make predictions using the data that I have to kind of decide when I want to plan a camping trip. Maybe I want to plan it in September or in May, when the temperature is still warm, but not too hot. Or maybe I want to figure out what the best time of year is to go to the beach, and I want it to be super hot. Well, I'm probably planning it July, August, maybe even June there. I can make predictions for next year, even though the data might not be for this current year. Okay? So that's what we've got. All right. So quantitative data, best with line graphs. Now, the other type of data that we're going to be talking about is categorical data. And to be quite honest, if I'm looking at the remaining blanks for this section, this page here, all of these blanks say categorical, because bar graphs, circle graphs, and pictograms or infographics, I can't talk and write, categorical, are all used for categorical data. Now, what categorical data is when I ask a question and you respond not necessarily in terms of a measured number, but respond in terms of like a category. And by category, I might mean something like, what pet do you own? Or, I don't know, what's your favorite time, or what's your favorite type of extracurricular activity? Or, which of the following items do you like, or in the uniform, right? Your answer is part of a category. It's not necessarily a numerical value that you have measured. It can be, but these following three graphs are best used for categorical data. Now let's talk about why we would choose to use one over another, because each of these different types of graphs still have advantages in certain situations and disadvantages in others. Now, bar graphs are pretty great graphs. They're pretty versatile in what they could be used for. So, for example, here's just straight up categories of what are the score ranges or different scores that people maybe have earned in a course. Maybe it's a university level course, we don't know. But we can see that the different categories here is I scored an A, a B, a C, a D, or an F. Okay? And those are all the letter grades. The thing about a bar graph is that bar graphs are really great because they actually say the number of responses in each category. So this says the number of students who scored each of those grades. But we could also talk about like the number of people who own an animal such as like a cat or a dog or a bird or a reptile, etc. Now, the main advantage of a bar graph is that a bar graph is particularly good when respondents can select multiple options. So again, taking it back to this example of which of the following pets do you have at home? Dog, cat, bird, reptile, other, none. Now, in theory, you might have more than one pet that fits more than one of those categories, right? You might have a dog and a cat. You might have a bird and a dog, right? You don't have to be isolated into one category. And a bar graph is really the only one of these graphs that we have here that can represent that data in a useful and easy to interpret way. Circle graphs can't do it at all. Okay, so circle graphs cannot represent data when there's more than one option that people can select. Same idea with pictograms or infographics, not really a great choice for that. But bar graphs, fantastic for it. Okay. If I wanted to look at this data, again, I could see a trend. I could say that most people in the course would tend to score like that middle grade level of a C, right? And if I said 3 years from now, if another class wrote the same assessment, where would I anticipate the students to score? I would predict, based on what I'm seeing in this graph, that most people would again score around that C range. If I didn't do anything different to my teaching, if I didn't do anything different to the assessment, right? Because the idea is that I could see trends or patterns, but I could also use those trends and patterns to make a prediction. So that's bar graphs. Next is circle graphs. Circle graphs are best used when they show parts of a whole or a percentage of a population. So if I'm talking about a circle graph, I want all of my categories, if they're labeled in percentages, to add to 100%. Or if I'm showing all of these as like fractions, I want all of those fractions to add up to 1. Okay. Now, at the beginning of the unit, let's kind of scroll back here. At the beginning of the unit, there was 2 graphs we looked at, and there's one in particular that we hated. It was this one. This one we hated because, as someone pointed out, all of the percentages add up to more than 100. This graph here is not a circle graph because circle graphs, if they have percentages, will add up to 100, which is why it was such a poorly designed graph, because it didn't do kind of the data justice in this particular layout, because we were anticipating different information here. And so we were pretty upset about it. I remembered us all being riled up about the disgustingness of this graph. Anyways, the idea is that circle graphs will always add up to 100% if we're talking about percentages there. The other piece, when we're talking about circle graphs, that we just kind of want to keep in mind, this graph is really good. It has a title, it has labels, it's color coded. It even tells me those percentages straight up, as well as these numbers here likely represent the number of people in each category. Kind of like a bar graph has the number of responses in each. You could still represent that data kind of in a circle graph, but again, circle graphs could only be used if you're only selecting one of the possible responses. You can't select options. You can't select multiple options. Now, for the circle graph, this graph would be much worse if I didn't include this data. And the reason being is that when I'm looking at a circle graph, visually speaking, I can see which category is the most popular and which one is the least popular. But if I'm being quite honest, I have a hard time visually distinguishing between the light blue, the orange, so the sci-fi, the comedy, and honestly, the action looks like it could be a similar size in my mind as the light blue of sci-fi and as the orange is comedy. So without those percentages there, if you said what was the second most popular movie, like I might be able to get action. But if you said what was the third most popular movie, I don't know if I would be able to distinguish that those two are identical in size, sci-fi and comedy, or if they're slightly off. Like if it was 19% and 20%, I don't think I could do it. So having those labels there are particularly useful to help provide clarity to that data. And again, when we're talking about good data will allow us to to acknowledge trends and patterns, as well as make predictions for the future. So let's say SPEV was having another movie night, and they collected data from a sample of the student population to figure out what people's favorite type of movie was, and they got this data as a result. Well, they might choose at their next movie night to play a romance movie because it's going to be the most popular category, so it'll probably appeal to the most number of people. Now, SPEV doesn't have the time and energy to every single year to collect a sample of data from the school. So if they collect it once, they might use that data to make predictions about what they should do in the future as well. So if, say we collected that data this year and we had a movie night next year, well, I know some of the students are different, but we might say, you know what, romance was pretty popular the first year. It's likely that romance is still going to be quite popular. We're going to play another romance movie at the next movie night. Okay? So just things to kind of acknowledge. We could acknowledge patterns, make decisions off of things, and we could also make predictions in the future. The last type of data is a pictogram or an infographic. These can look a little bit different. The pictogram and the infographic is, I would say, the least mathy version of a graph. And quite honestly, these types of representations are best used to show data to a greater population. So say we're talking about the government wanting to share data about, I don't know, mental health or pandemic data or things like that, where they want the whole population to be able to see and interpret that data. Well, if I showed them something in a line graph or showed them something in a bar graph or even showed something in a circle graph, it might be hard for the general population to interpret because the general population might not have those math skills locked and loaded like we in grade 9 now do. So we want to make sure that data is easy to read. It's represented in like a user-friendly way that hopefully everyone can kind of understand. Now, without looking at any of these words here, something that I see is that 2 out of the 10 people here must have some sort of similar outlook, and the 8 of the 10 people have a different but likely similar outlook. And again, I'm not even reading any of the words here, but just I can see that if you're dressed similarly, it's likely that you are done, or it's represented that way because there's some sort of similarity between the two of them, right? So this is some sort of connection that I'd say most people are able to make. So it's a good way to represent data for the general population there. Pictograms or infographics are often the best option when I want to use a limited number of possible responses. So if I had 10 people here and I all colored them in 10 different colors, I don't know if a user of, just a general person in the population, if I would look at that picture and go, oh, that must be 10 different opinions. Or if I would look at it and be like, yes, I'm just looking at a crowd of people. Right? Maybe it's just a picture of 10 people. There's no sort of math connection with it. When I have 2 options, that makes it a little bit more obvious. And so pictograms and infographics, good for limited number of possible responses. Doesn't mean that's the only time they're used, but just if we're trying to make decisions of what we should use, that's kind of what we're thinking. That's our thought process. Okay. So first of all, hopefully we can look at our data, kind of see what category our data falls under, and then make a useful selection of how to display that data. Now, you are going to learn how to make different types of graphs. I would say bar graphs and circle graphs are what we're going to focus in this unit. But hopefully by the end of this unit, you'll be able to kind of make those 2 graphs. Now, once we've displayed data, the other piece to that is to analyze that data. Again, we are trying to display that data and identify patterns and trends so that we could later use our results to make predictions going forward. And we talked about that in all of our examples there. We talked about how SPEV would notice that romance is the most popular, and it would predict that next year, even though they didn't collect the data next year, they collected it this year, that they would continue to play romance movies because it would likely be a similar trend they're noticing. Okay? So what we're going to do in the last two examples we're going to look at some data that's provided to us. We're going to try and acknowledge a pattern or a trend that we see. A pattern is something where it kind of follows a particular scheme. So it might be going up, then down, then up, then down, then up, then down, then up, then down. Or like red, green, blue, red, green, blue. A trend is something where over kind of one variable, maybe it's over a period of time, maybe it's over a span of ages or something like that, we see a general direction of the data. So we're going to talk about this particular example here, about a graph that represents the number of collision claims per 100 vehicles insured for male drivers in Alberta in the year 2004. So the 100 vehicles piece refers to that they looked at 100 vehicles that were driven by male drivers. Okay, this data has nothing to do with females. This data is particularly focused on males. So we're talking about our population. Our population would be our male drivers there. Now our population was kind of separated by age bracket here, and we can see that on the horizontal bottom axis that we have 19 to 20-year-olds, so pretty fresh drivers, pretty new drivers, then 21 to 22, 25 to 35, and they just get older and older as kind of time goes on. And then on the vertical axis, the up and down axis, we have the number of claims. So if you get into a collision, you got to make a claim with your insurance company so that the damage can be paid for by that insurance company, and you paying your deductible so that the cars can be fixed or whatever damage is caused in the collision can be fixed. Okay. Now, if I'm talking about a trend going on here, I think it's fair to say or safe to say that we can see that as the ages of our male drivers goes up, the number of claims go down. When we're talking about a trend, we want to talk about those two kind of variables in our data, and not just saying it goes down, right? We want to be more specific. So here I see as our male drivers get older, the number of claims, I cross it out, the number of claims goes down. So that's how we're going to identify this trend. The older the male driver, the lower the number of claims. Right, really drawing the connection between those two variables in our data collection. Okay, so that was a trend that we acknowledged. Now we're going to do an example piece where we want to make a prediction. So let's say we collected this data for an insurance company. Now insurance companies often charge people extra money based on the high probability that they'll be in an accident. Based on the graph, which drivers do you think are most likely to be charged extra money, aka which drivers are most likely to get into an accident? Well, taking a look at this data, the number of claims for the data they've collected that was the most was for 19 to 20-year-old male drivers. So if I wanted to make a prediction, I would predict that that's true for more than just 100 vehicles, but for all of the vehicles. I would say that 19 to 20-year-old male drivers would be most likely to get into an accident from that particular population. So males or male drivers aged 19 to 20. So I know you don't have your licenses yet, but this is typically a true statement. If you get your license and you are just starting off, your license tends to be like the standard price. If I remember correctly, my license when I first started was about $60. Now, as you get older, likely, and based on this data here, you typically get more and more experience, and you typically become a better driver, right? You're just more used to it. You know that your reaction time has to be, maybe it gets a little bit better. Maybe you're more cautious, whatever. If you drive without an accident as you age, your cost that you're charged for your license actually decreases. There's a merit system in Manitoba. So the more years that you drive and as long as you don't get into any accidents, your charge for your license goes down. Now, if you do get into a lot of accidents at any age, you're causing the insurance company a lot of charges, right? Because when you get into an accident, you don't pay for all of the damage you caused. You pay for some sort of deductible. Maybe you pay $200, maybe you pay $500, depends on your insurance. Now, if you get into a lot of accidents, that insurance company pays for the damage. And if you cause a lot of damage, they're going to be like, hey, you should be charged more to help cover these costs. So they will charge a premium for people who get into more accidents, because if you're like, you already have got into lots of accidents, you're more likely to continue getting into those number of accidents. So just something to kind of be aware of. Last example that we have here, this is an infographic. This is one of those easy to read question or data representations that hopefully most people of the general population will be able to interpret. And it's about how car color and crash risk are associated. So, just taking a look at this, I'm looking at white and gray cars at the top. It says increased crash risk, and it has 10% with them. So, I'm looking at white and silver / gray cars are the most likely to get into a car accident or get into to a crash, followed by red, then black, then blue, then burgundy, then green, then yellow. Okay, so this is the data that was collected. Now let's talk about how a manufacturing company might use this information. So put your minds into the perspective of a manufacturing company. You're a business. Any business, their goal is to make money. Now, if there is no car accident ever, then the amount of car sales that exist goes down, right? Like if I'd ever gone into a car accident, 2 years ago I was rear-ended, my car was totaled, I was not able to continue driving it, so I was forced to buy another car. If I wasn't in that accident, I would probably be driving that same car today. But if you're a manufacturing company, you don't really want there to be no car accidents. Like, you don't hope for people to get injured, but you don't want there to be no car accidents because you want to sell the most amount of cars. And so the more accidents, the more cars you could potentially sell. Okay? Think about the cars you see on your road. Very likely that you don't see cars of this color quite frequently, right? Like unless you drive one of those colors and you're like, I see it every day because I'm in it every day. Okay, different story. But if you're just driving home, and when you drive home today, like take a look at what car colors you see most frequently. White and silver are the most common car colors. And manufacturing companies actually make cars that are white and silver / gray most frequently, and they'll often charge less for someone to have a white or silver car. Why? Because they're more likely to get into a crash. Why do they want that? Well, it's because if the car gets into a crash, then someone's going to need to buy another car, which means that they'll be able to make more sales. So that's how that manufacturing company would use this information. Let's write that down. the manufacturing company may make more white/gray cars because the more collisions the higher their number of sales. Okay, so true story. I had a friend who just recently purchased a vehicle. Their old vehicle was just old and, breaking down, so they figured it was a time to buy a new one. But their old vehicle was like this beautiful bright blue. And they loved it because every time they went and parked in a parking lot, it was easy to spot because there's not a ton of bright blue cars out there. So when they were going to buy a new car, they're like, okay, it's going to be this bright blue again. They bought a brand new car. And if they wanted it in blue, they would have been charged thousands of dollars more just to get it in blue. And now cars are already expensive enough, so they didn't choose to go with the blue option because, do they really need a blue car that badly? They use those thousands of dollars for other things. They ended up going with a lower, cheaper car option. And that cheaper car option was a gray car. So just things to kind of keep in mind, like manufacturing companies, knowing that they won't make more sales if you're not into a car accident. So those car colors that don't get into as high of collisions, they might charge more for because they know they're not going to make those sales as often. Other side note, what cars or vehicles do you see that are yellow most often? School buses. School buses are yellow because yellow, as we see here, has the lowest risk of being in a car accident. Well, duh. We want our children that are our precious cargo to be as safe as possible. And how do we get them as safe as possible? Well, we want them to be in a high visibility vehicle that people can see. And hopefully, if a bus rolls through or slides through a red light because it's really, really, really icy, it gives people the most amount of time to spot them and hopefully stop so they don't get into an accident with that bus. So if you're a bus manufacturing company, obviously you want to make more sales, but more importantly, you want to keep the kids safe who are going to be in those vehicles. So when we're talking about buses, they will make school buses are made yellow for that reason. Okay, there is practice that follows. The practice that follows has 3 parts. Part 1, Part 2, Part 3. I need you to skip Part 1. Part 1, we will talk after you've had after you've had your first day in the computer lab. But until then, do not do Part 1. Go to Part 2, Part 3. We will also have a class time where you're working on that 4.6 practice. So start it, but if you don't finish it, that is okay because you'll have class time to do so. Otherwise, that is it. Have yourself a wonderful day, and I will hopefully see you soon. Bye.